In level 3, you'll be given a function that you might not know how to factor, but you'll be given one of its roots or one of its factors. And the goal is going to be to use polynomial long division or synthetic division to divide the polynomial and get the function in completely factored form, and from there you might have to graph it or answer various questions, but the basic gist is our goal is to factor something that we normally wouldn't know how to factor given one of its factors or one of its roots. So looking at this first example, we have a polynomial f of x that we normally wouldn't know how to factor, and we have one of its factors. So that means f of x is going to be equal to x plus 2 times some other factor, and we don't know what that is, but we can find out what I would multiply x plus 2 by to get f of x using long division. So I'm going to divide x to the third plus x squared minus 4x minus 4 by x plus 2. And I can do this using long division or synthetic division. I'm going to use synthetic division because to me it's quicker. So when you use synthetic division, remember to choose the 0 of the expression you're dividing by. So what number actually makes it equal 0? In this case that would be -2. And then I put a shelf and I put all the coefficients of the expression on the top of the fraction that I'm dividing. And so x to the third has a 1, and then that's a 1x squared minus 4x and minus 4. I make another shelf. I bring down my first number, 1. I multiply -2 times 1 is -2. I add 1 plus -2 is -1. I multiply, I get 2. I add -4 plus 2, and I get -2. Then I multiply, we get 4. We add, and we get 0. And since I'm supposed to be factoring this expression, I better get a 0 here. If I didn't get a 0, that would mean I had a remainder and the expression wasn't factorable. So I know I messed up if I get a remainder, because there should not be a remainder for an expression that's factorable. Okay, so when you divide these polynomials, the answer you get using these coefficients here, remember this starting on the right side, the first one's your remainder, the next one over is your constant, the next one is your x, and the one on the far left would then be your x squared. So we get x squared minus x minus 2. And so I can put that up here, and we get f of x equals x plus 2 times x squared minus x minus 2. And now I have something, it's not completely factored, but I know how to factor a quadratic expression. So the rest I can do just by factoring. So I factor x squared minus x minus 2 into two binomials, and we get minus 2 plus 1. And now I have f of x completely factored. The question was, what are its other polynomial factors? Its other factors, besides x plus 2, are going to be x minus 2 and x plus 1. In this next example, we are given a function, again, that we wouldn't know how to factor normally, but we're given two of its zeros. And our goal is to find the other zeros and write the polynomial in factored form. So we always want to write the polynomial in factored form. So f of x, since I'm given two of the zeros, if it has a 0 at 3, x minus 3 would be a factor. If it has a 0 at -5, x plus 5 would be a factor, and then I don't know what the other part is going to be, so I'm going to use long division again. And again, I'm going to use synthetic division, because if I have linear factors, synthetic division is faster to me. So remember to use this last example combines our last skill with this skill. We want to graph this polynomial, and in expanded form, I can tell the end behavior, but I can't tell the zeros. So I need to factor it to be able to tell the zeros. Normally I wouldn't know how to factor this, but since I'm given one of the zeros, I can factor this expression using polynomial long division or synthetic division. Since -1 is a 0, g of -1 equals 0, in factored form, g of x is going to be x plus 1 times some expression. And from there I'll be able to factor it. So to figure out what that expression is, I use long division. I'm going to use synthetic division again because I think it's easier. So remember to put the 0 in front. So if x plus 1 is a factor, I put a -1 in front. I put my shelf. I put my coefficients, 1, -5, 3, and 9. I put my second shelf. I bring down the 1. I multiply. -1 times 1 is -1. Add -5 plus -1, and I get -6. Multiply -1 times -6, and we get +6. Add 3 plus 6, that's 9. -1 times 9 is -9. +9 plus -9 is 0, which is good. I better get 0, otherwise I did something wrong, because there shouldn't be a remainder. And I get g of x equals x plus 1 times x squared minus 6x plus 9. And then I can factor that a little more. This is x plus 1 times x minus 3 times x minus 3. So in factored form, g of x is going to be x plus 1 times x minus 3 squared. And now I can tell its zeros. Its zeros are going to be at -1 and +3. And then since we're graphing this, we need to think about their multiplicity and whether they will cross or bounce. The 0, -1, its multiplicity is 1, so it's going to, since that's odd, it's going to cross. And the 0 at 3, since its multiplicity is 2, which is even, it's going to bounce. And the thing I'm missing to be able to graph this, besides x-intercepts, I need to think of end behavior and I need the y-intercept. So for end behavior, I look at the very first term of the expression. It's an odd degree with a positive leading coefficient, so the end behavior is going to look like that. And the y-intercept is what you get when you plug in 0 for x, which is going to be 9. It's easier to plug in this form up here because everything becomes 0 except that 9. And then I plot all my points, so I need an x-intercept at -1. I need an x-intercept at +3, a y-intercept at 9, and now I can go ahead and draw the graph. At -1 I'm supposed to cross. I start down below because of the end behavior. I go through my y-intercept and I have to bounce at 3. So something like that.